Hello students. Today we're going to talk about lists in Python. Lists represent a sequential collection of data values identified by an index. You can think of a list as a way to store a collection of other data values or variables. Each value in the list is called an element. Now we've talked a little bit about strings before, and lists have many of the same properties as strings, but they also have some unique and interesting properties. Lists can be created in many ways. The easiest is to simply enclose values in square brackets separated by commas. For example, we could create a list called listx by creating a variable with that name and setting it equal to the code that you see on the screen. Here we are adding to our list a string hello, a string world, the integer 7, and the Boolean value true. Now this raises an interesting point. Elements of a list do not need to be the same type. So in this case we have three different types of elements. This is an important distinction that Python makes from other languages, where often lists and other similar data structures will require that all elements be the same type. It's also possible for a list to contain another list as an element. The interior list is called a sublist. Lastly, there's a special list that we'll talk about, and that's called the empty list, which is simply an open and close bracket with nothing inside of it. Now, as with strings, lists have a len function that returns how many items are in the list. For the purpose of the len function, sublists are considered to be a single item. So for example, if we look at the line of code here, we can call the len function on a list, and this would return 3. The reason for this is that the three distinct elements are the integer 1, the integer 2, and the list 3, 4, 5. Now this interior list would also have a length of 3, but in the outer list it acts as a single element. You can use list length with for loops and while loops to help iterate through a list. Another common way to iterate through a list is simply to use it inside of a for loop. A list is what's called an iterable object, which means that the Python interpreter knows how to move through it automatically. So for example, if we were to create a list of names for Alice, Bob, Candy, and Dimitri, then we could simply use a for loop to say for each element j in the list names, we'll print out hello followed by that name. So this would print out hello Alice, hello Bob, hello Candy, and hello Dimitri. If you want to access a single element directly, there's a special syntax for that, and it's the same syntax that we use to access a character in a string. First, we have to reference the list by the list variable name, followed by the index in square brackets. So for example, if we create a list of numbers and set that equal to 17, 123, 87, 34, 66, 8,398, and 44, then we can use numbers with some index to retrieve an element from the list. Now remember, indexes, just as with strings, are zero indexed. So if we ask for numbers sub 2, what are we going to return? In this case, it'll be 87. Numbers sub 0 would be 17, numbers sub 1 would be 123, and numbers sub 2 would be 87. There are a couple of Boolean operators that work specially on lists, and in fact these work the same as they do on strings as well. These are the in and not in operators. They check for membership. So the in operator returns true if the item is in the list, and not in returns true if the item is not in the list. For example, if we create a list of fruits, and we say apple, orange, banana, and cherry, then we can invoke the print statement and print apples in fruits. If we do this, it will print out the Boolean value true. If we check for pear in fruit, then we'll get the value false. There are two other special operators for lists, and those are the concatenation and repetition operators. The concatenation operator is the plus symbol, and it works the same as it does with strings. The concatenation operator requires two lists. It takes one list on the left-hand side and one list on the right-hand side and simply appends them together. So you'll get all of the elements in the left-hand list followed by all the elements in the right-hand list, all as part of one new larger list. The repetition operator performs repetition, which duplicates all the items of a list in order. What this means is that if you create the list 1, 2, 3, and then use the repetition operator to multiply that a certain number of times, say 2 times, then you'll actually receive the list 1, 2, 3, 1, 2, 3, because it takes each of the items in that list and then appends them in order to the list the set number of times. If you were to do 1, 2, 3 times 3, then you would get 1, 2, 3, 1, 2, 3, 1, 2, 3. You can also use a slice operation on lists to extract sublists from a currently existing one. In this case, you use a standard list syntax, except you use a colon, followed by, or rather you have your starting index, a colon, and then the closing syntax, or closing index as the reference point for your list values. This will return all the lists from the starting index to the ending index. Now, one of the big differences between strings and lists is that lists are mutable. If you remember from our discussion of strings, we talked about how strings are immutable. That means that their elements couldn't be changed. You couldn't pick one letter out of a string and change it with another letter without completely erasing and recreating the whole string. Lists don't have that property. Lists can have their elements changed. So for example, if you try the code here, we can create a list called fruit and give it banana, apple, and cherry, and print out the list fruit. Then we can actually set fruit sub 0 to be equal to pear. And if we print out the list now, we'll actually get pear, apple, cherry. We replace the first index item. We replace banana. It goes away, and instead we insert in its location the string pear. And this is a fundamental difference with how lists work compared to strings. In fact, when you are working with a string, it's stored as a single collection of letters, and in the computer's memory, each character in the string takes up 16 or 24 bits, and it's a fixed size. And so if we know that we have a string of 5 characters, we just allocate the correct amount of memory for it and then store the different characters in order. With a list, we instead use something called pointers, where we say the first element of the list could be an integer or a string or another list. We're not really sure. And so we're going to give it a special name, and that's the list sub 0. And then we're going to actually store with that a pointer to the second item in the list. And with the second item in the list, we're going to store a pointer to the third item in the list, and so on and so forth. And what this means is that when we want to change the second item in the list, all we have to do is say, well, we'll create a new place in memory, we'll change the pointer to that new place in memory, and then pick up the pointer from the old second item and point and use that as the step forward in the new item. And so in this way we can swap out one value inside the list for another. Now, because lists are mutable, we can add or delete items from within the list instead of simply changing them. We have the del function, which takes a list followed by an index, or a list variable name followed by an index, to remove a single item from the list. We can also use list.insert, where list is the name of our list, and insert is a function on that list, where we can insert an item into the list at a given index. Everything at that index and forward is incremented by 1, and everything before that index is left alone. So for example, if we have apple, ball, and cat, and we want to insert Batman after ball and before cat, we would say insert words.insert at index 3 the string Batman. And what that would do is change the index of cat to to be 3 actually, and then the index of Batman would take on 2, which is the previous one. And again, the way this works is by how the different types of collections are stored. Assigning the same string to two different variables creates an interesting effect in Python. Both strings point to the same object. All variables in Python work with the use of pointers. When we create a string call and store it in the variable name, what we're actually doing is we're saying this word name, whenever it appears in our program, we want the computer to reference a specific location in memory. And then we can take that same string and call it a new variable called name1. And if we do this, both of these variables will point at the same spot. That means that when we delete one variable, the other one still exists. Because strings are immutable, they're considered a concrete value, and so we only need to store one copy in memory. And if we change one copy and we use the correct syntax, then it will also change any other copies that point at that same variable. Now, Python is pretty good at this, so if you create two variables, name1 and name2, and change one of them, what it'll generally do is say, okay, are these two variables still trying to point at the same thing? And if not, let's create a new spot in the computer to store the new variable. And so as long as there's something pointing to the old string, it's left intact. But if it's no longer referenced, if you only have name1 and you change the value of it, it'll actually create a new string and then delete the old one. One of the things to take away from this is that this is actually a lot of computing power that goes into managing these strings. Creating and removing things from memory is not generally a cheap operation in terms of computing time, so string operations are quite costly. Lists, on the other hand, are mutable, which means they can be changed. If you create two copies of a list and assign them to different variables, they will point to different objects. Each of these lists can be changed without impacting the other. And this represents a major idea in computer science, and that's that we sometimes store objects by value rather than by reference. Immutable objects are stored by reference. Since they are unchanging, only a single copy is ever stored in the computer's memory, and all variables that hold that value point at that copy. If we want to store some integer, some special integer, and say this happens to be 7, and we create 5 different variables that all point to it, we're not going to store 5 different copies of the number. We'll store 5 pointers that all point to this one location, and we'll have a counter that keeps track of how many we have, called a semaphore. And when this counter reaches 0, that memory is freed up and something else can be stored there. But as long as there's at least one, it'll stay in memory. And any new variables that are created can also point to it if they need to. With mutable objects, they are stored by value, and each copy is stored independently since it may be changed. This has the effect of making mutable objects take up quite a bit more memory than immutable objects. And this is one of the nuances that may come into play later on when you start writing more complex and larger programs, is how do you make use of a limited amount of memory, such as you might see on a smartphone or an embedded processor. Most modern desktop and laptop computers have plenty of memory, but not every system does. And so depending on your program, you might need to make changes in terms of how you store variables. I think that's all for this lecture. I think we're going to continue on with dictionaries next. Thank you guys. Have a good day.